Hello, my scientist friends. It's great to have you back. It's episode 2 of Hot. You may be thinking, what am I wearing? Well, it is lack of heat in here. Did you learn anything from last time? It's lack of heat. We're talking about cold reactions. And so it makes me remember the times when it's really cold and I might wear stuff like this. Check out the crazy hat. I like it. By the way, it doesn't fit my head. It's really tight. But I'm wearing my goggles for safety and I've got my gloves on and it's really sort of lack of heat in here because today we're doing endothermic reactions. Now, I'm actually not going to do my experiments with all this stuff on, but it just reminds me of the different things we've been doing. You know, yesterday, or in our last episode, we were talking about the difference between heat and lack of heat. We call it cold. Remember we talked about this? There's light and there's lack of light, and there's heat and there's lack of heat. Well, in this video, what we're going to be talking about is, we're going to be talking about not the heat reactions, we're going to be talking about the endothermic reactions, okay? So I'm going to put my safety stuff on and get ready. Oh yeah, that reminds me. Definitely have to have my goggles today, okay? And so let me get my stuff on as I get ready. Getting ready for what we're doing today. I'm actually going to put my apron on too. There's going to be some stuff that could get on my clothes, and I really like my shirt, so I don't want to get that on me. But just a quick reminder, okay? Let's see how much you remember. In the last video, we were talking about the difference between heat and lack of heat. Remember, we talked about energy moving from one place to another. That's how you can tell, okay? You can't really tell if something's hot unless you get your hand close to it and the heat goes to your hand. So maybe when you put bread in your toaster, okay, you can feel the heat that's coming out of it, or you put food in a microwave and you can feel the heat coming off of it. You can tell, okay, I know that's hot because it's giving off. Okay, so in the last video, we did heat exiting, which was exothermic. It's giving off heat. In this one, we're going to talk about endothermic. Okay, now, in all honesty, a lot of reactions that we can do at home are exothermic reactions, okay? There's not a whole lot of endothermic reactions, though we're going to do some really cool ones today. But I'm going to start with an exothermic one like last time, and this one's really sort of cool. And so what I'm going to do is make sure I have my goggles. And so what I'm going to do is I'm going to take powdered soap. Okay, now this can be soap that you put in your washing machine. It needs to be powdered. Or this one's actually a pod from our dishwasher. Okay? And so what I'm going to do is I just cut the corner off of that, and I'm just going to pour a little of that detergent in my hand. So it's powdered detergent. Okay, powdered detergent. And what I'm going to do is I'm going to add a little bit of water to it. Okay, in my hand and mix it up just a little bit. Okay, so it's going to, and it's already going. I can feel when this dissolves into water, it gives off heat. I can feel it with my finger. Now it's just soap, so it's great to touch, but I can feel it in my palm. So parents, you could do this and let your younger kids touch it and they can feel that it's warm, or they can put it in their hands. And the cool part about it is just soap. But when it dissolves, it gives off heat. It's exothermic, okay? So exothermic heat is going out, and so it feels hot because the heat's going from there into my hand, okay? And I feel it as warmth. It's exothermic, okay? So those are the ones we learned last time. Now, that's a really cool one, and it's got soap on my hands, so washing, getting it off really, really good. Okay, that works awesome. But today, so that's exothermic, heat going out. Today what we're going to be talking about is endothermic reaction, heat that's going into a system to make it work. Now, in the last video, we were talking about dry ice. Now, a couple things I want to make sure people understand before I do this, okay? I showed you a couple of cards, and I showed you that ice is 0 degrees Fahrenheit. Now, I know, and many of you know this, that water doesn't freeze at this temperature. This is the temperature that was on my freezer when I went to use it. So let me explain. Water freezes at 32 degrees Fahrenheit. But if I want that ice to be really cold, or things in my freezer to really stay frozen, I got to get way below that. So not 32. I don't have it right at where it freezes. I have it where it's way below that, so it's really cold. So this was the temperature of the ice that came out of my freezer. And then we were comparing it to dry ice. And we said dry ice is not water, actually. It's actually carbon dioxide, the gas that we breathe out all the time. And it's super cold, negative 110 degrees Fahrenheit, super cold. So what I want to do is I want to show you some things, because what's happening to dry ice is endothermic, okay? It's going to be taking heat from the room, and it's going to make it go from a solid, not to a liquid, it's going to jump from a solid to a gas, okay? And so, reminder, you have to wear safety gloves for this, okay? Now, these are just work gloves. You could actually use gloves like the ones I started with, Okay, you could use gloves like you were going to go outside if it's winter time. Those work great. Something to insulate your hand. It is too cold for your skin. Okay, now I'm going to show you something really cool about it. Now, not only do I have these dry ice pellets, okay, and so just a reminder, remember I was dropping them in water? Now listen, it's bubbling. Miss Christie's going to get close so you can hear that. We talked about this fog bank, and I want you to be able to see this again, because man, that is working awesome. And so what is bubbling is, when I throw this piece, let me grab one more to compare them real quick. Throw it out on the table. It's giving off that fog by itself, okay? But when there's one right there, and it's giving off that fog, okay, so it's going from a solid to a gas. So what I'm trying to do is get it to do work for me. There you go, you can probably see it when it bumps a little bit, okay? And so what I'm trying to get it to do is, I'm getting it to do work, and you'll see this in sci-fi movies and things like this, but what is happening is, those bubbles are that carbon dioxide gas that comes up, and it's actually so cold in the water that some of the water is becoming vapor, and I get that fog bank, okay? Using a lot of science fictions. Now, for parents that want to take on something a little more interesting, here's a cool one. I used to work with a lady whose name is Miss Paula, and she used to carbonate. Okay, so the carbonation that's in drinks comes from carbon dioxide. And one of the things she would do in her physics class is she would find root beer flavoring. You can find it at a store. And you would have to look up the recipe online because I don't know it exactly. But she would take a big container, root beer flavoring and water, and she would drop dry ice into it so it bubbled up and it would carbonate. Now, it's not exactly like the root beer that you would buy in a can or a bottle, but it has obviously that flavoring, and she would carbonate it. The kids would do that and mix it up. Pretty cool experiment. But that's another thing you can do with carbon dioxide. So kids, if you like sodas at all, that carbonation, that bubbling, when you open the top, it bubbles, doesn't it? Yeah, it's the carbonation that's inside, so the bubbles are coming out. In this case, I'm just getting it to do a little work for me. It looks real science-y looking, okay? But it's so, so cold. Okay, now I want to show you how cold it really is. Now I'm going to take a couple of pieces as Miss Christie gets close over here, and I'm going to show you what happens with metals. Now I showed you this is cold. This is just a regular spoon. Whenever metals get cold, they contract. I want you to listen carefully. Watch. Isn't that crazy? When I stick that to that spoon, that metal almost screams. Sounds like a horror movie, doesn't it? That metal is contracting. It's getting so cold so quick, it's actually making a sound. If I did it on a pot, that one's not very loud, but if I put it on the handle, oh, I'm opening a creaky door. I wonder what's inside. That's sort of scary sounding. Okay, you can do it on different things. It works on metals. Sounds like scary movies, doesn't it? And what's happening is metals contract, they get smaller. And since I have dry ice, I wanted to show you that really cool thing about it, because if you get some of it, you want to try some of this. Try different metals. All of these are stainless steel. You can try other metals that you might have and see what it does. Always do it on something you're not worried about damaging it. Okay, now none of these are damaged, but I wouldn't want to do it on something that's very expensive. Okay, it's just so cold. The metal is contracting and it's making a sound. Now, if I put it to glass, it doesn't really do that, okay? It doesn't really do that. And so you have to try it out on stuff. Cool experiments, because that's what experiments are. You're trying it out and you see what happens. Okay, so dry ice, okay? Super, super cold. Now, here's the thing about it. Remember we said heat is a movement of energy. Well, if this is so cold, when I put it out on the table, the heat of the room is going inside there and it's causing it to change. When I drop it in the water, here's another piece. When I drop it in the water, what's happening is the temperature of the water, which is not that temperature, is causing it to change. Okay? So I'm causing energy to go into the dry ice. That's why it's called endothermic reactions. So energy's going inside. Okay? And so if I were to grab that, oh, I'm not going to. You remember the safety on this? We said it's too cold for our hands. Okay? But even with gloves, as you hold it, okay, after a little bit, you can feel it starting to get cold. Okay? Why? Because it's trying to pull energy. Okay? So energy is moving inside of that. So we're using dry ice to do that. Now, if you take something as simple as just regular ice, just as a review from last time, I'm going to get an ice cube out of my freezer. And again, it says it's 0 degrees. All that's happening is the same thing that's happening with the dry ice. Heat from the room is going inside there, but it's not going to go to a gas. It's going to go to a liquid, right? It is endothermic. And if you, for my older kids, if you're high school kids, this is thermodynamics, okay? This is what you're going to have with delta H numbers, where energy is moving from one place to another. We can find it in reactions, or we can find it in something very simple as a phase change. It takes energy for it to go from one place to another. Now, parents, here's a cool one for you. When we talk about foods, kids, whenever we get foods, we get energy from our foods. When I eat something, when I take a big molecule, I eat sugar, which is a really big molecule, and I eat it, it goes into my stomach, it cuts it up into really small parts, and the energy that's given off from those bonds is the energy I get. But parents, have you ever heard that if you eat celery, for example, or lettuce, those kinds of things, that takes more energy to break it down than the energy it gives you? That actually falls under endothermic. You're putting energy in to break that bond, but it's not giving off enough energy to actually give you tons of energy in your diet. And so by breaking it down, you're actually, if you're eating it, you're actually using more energy than you get, and so it's actually using calories, okay? So there's lots and lots and lots of science to all the different things we're doing. Everything from thermodynamics to entropy, all those things going on at the high school level, to things melt, things don't melt. Energy going in. And so what we're going to do is look at another example. I'm going to get rid of this ice from my refrigerator, and I'll put this dry ice back into this ice chest, because we're going to come back to it in a minute. Probably going to do one of the coolest things today, but what we're going to talk about next is something really different. This is a cold pack, okay? And this is a cold pack. If you were to hurt yourself and you bruised yourself and you needed to have a cold pack, oh, I hurt myself, I don't want it to swell up or anything like that, you get a cold pack. Now the instructions on this say what you're going to actually do is you're going to take it at the bottom and you roll it up until you hear a pop sound on the inside. So basically you have a powder inside and you have a baggie that's got liquid in it. And so when you start to roll it and you hear that pop sound, you've now released the liquid into the powder, and when you shake it up, in the reaction, it gets cold. So what I'm going to do is what you would not do is I'm going to show you what it looks like. Just going to show you what it looks like. So what I'm going to do is I'm going to take this and I'm going to open this up, okay? My scissors got used for something else, and so I'm going to take a little bit of a knife here and open this up. Oh, there it goes, okay? And so what I'm going to do is I'm going to put that away over there, okay? So here's what it is. Inside that cold pack is this powdery substance, okay? Okay, this powdery substance. And then what you're going to do is you're going to take this baggie and you're going to tear it open, and you're going to, let me use that knife one more time. Forgot my scissors. And I'm going to cause the reaction to happen. So I'm just going to squirt all that in there. Okay, squirt all that in there. Now, if you have one of these, you want to make sure, okay, notice I'm wearing my goggles. Don't want any of this on me. And then what I'm going to do is I'm going to mix that up, okay? So I'm going to take that spoon that I was using a while ago, and I'm just going to mix it together. Being very careful. And this one has a bunch of lumps in it, so I'm just going to break up the lumps, and I'm just going to mix them together. And what's happening is you're causing a chemical reaction. The liquid reacts with the solid, and what happens is, in that reaction, you have a drop in temperature. And so what happens is, as you let it sit there, it starts to get cold. The glass is really getting cold, okay? You could actually put your finger, yeah, wow, that's really cold. Okay, it's almost like ice water. It's really cold. And so and then I would make sure I wash my hands really good, but I can see that it's getting cold. So what's happening is, in this case, there's a chemical reaction that's happening between the powder and the liquid, and there's multiple versions of this, okay, of what chemicals are in here. But when you mix them together, okay, so would you do it like this? No, remember, it's inside this pack. And so when you roll it up and it pops, it's all inside, and you shake the container, and what I would do is use that cold on my injury, so I don't have a swollen elbow or an ankle or a knee, and it's going to pull off the heat. Why? Because with that heat, that swelling will go down. Okay? Now, many of you probably put ice on it. Ice does the same thing, but if you're not somewhere where there's ice, you'll find these in a first aid kit. Okay, now the only reason I opened it up is to show you what's inside, but this container gets really cold. Miss Christy, this one's really cold. Okay, and so this is a reaction that is endothermic. Why is it cold? Okay, so the reaction, when it starts, it needs energy for it to go. And so it's going to steal energy from what we call the surroundings, which is the glass, or when I touch it, it's going to steal energy from my hand. And so the reaction keeps going. What do you think would happen if you put it in the freezer? It almost stop. Why? There's no energy for it to steal. And so out in the regular room, or when you hurt yourself, it's really warm, right? And so it's stealing that energy for the reaction to go, but it's actually helping you by pulling the heat away. This one's a really cool reaction. And so this container gets really, 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 really cold. Now at the very end of this, so let's talk about this real quick, disposal. You want to make sure that you read on the container of how to dispose it if you do one like this. So make sure you read, parents, adults, make sure you read where you can dispose of it properly. Can it go down the sink or can it not? You just have to read the instructions. And most times in a pack like this, you can only use it one time. Because after you've broken it open and the liquid gets to the solid, the reaction goes, it'll go for a while and then it's over. Okay, and then you can dispose of it. And since this can go in the trash, it's very easy. If it can't go down the sink, you can take paper towels and absorb it and then get rid of that, put it back in the original container and get rid of it. So it's easy to do. So I test that chemical, so I'm just going to wash my hands really quick. But that's an endothermic reaction. Now, I got to make sure we got this, kids. Okay, exothermic. When I touch exothermic, it feels what? Hot. Endothermic, to my hand, is going to feel cold. So exo is hot, endo is cold. All right? And so that's what we're doing so far. Man, that one really got cold. That one worked out really, really good. Now, what we're going to do next is one that you've seen before if you've watched some of my videos, but we're going to do it in a really different way. We're going to take baking soda, okay? And we're going to take vinegar, okay? That reaction, okay? Used in a lot of volcano type things, okay? And what we're going to do is we're going to take a bottle. So I do a lot of them in bottles. That one has a little water in it. Shake that out. Okay, we're going to do a lot of things in bottles. It doesn't have to be in a bottle. You can do it in anything, but this one's really cool in a bottle. Okay, and then I'm going to have a little bit of blue soap. Okay, it doesn't have to be blue, but the soap's going to make it really nice. And then I have food coloring. In the last video, we did an exothermic reaction. And in that exothermic reaction, we made a warm volcano. In this one, we're going to make a cold volcano. Okay, so here's how we're going to do this. I'm going to take my funnel. And I'm going to take that spoon I used a while ago. I don't want to mix chemicals, so I'm going to wash it off really, really good. And so what I'm going to do is I'm going to get a good spoonful of my baking soda. And I'm going to shake it down in there. Get it down in there. Woo! Ready for a cold volcano. Okay? And then I'm going to, you get to pick a color. And so last video I used red, so I guess if they call this a cold volcano, I won't use blue. But I want to be different, so I'm going to use green. And so I'm going to take one drop of green. There it is. Okay? Being careful. And then I'm going to use a drop of soap. And you'll see why here in a second. Okay? Got me a little soap in there. Okay? Now, chemical reaction in this case is going to happen is I have a weak base. Okay? For my older kids, this is a weak base. Baking soda is a weak base. And this is a weak acid. Vinegar is a weak acid. It's acetic acid. So it's not a strong acid. It's not really anything that hurts you. We know lots and lots of things are made with acetic acid. Just in case you don't know, ketchup, mustard, pickles, they all have vinegar in them. Okay? And so we use it for things that we eat, but vinegar is used for a lot of different things. It's acetic acid and sodium bicarbonate. So it's baking soda and vinegar. All right? And so here's what's going to happen. As I get myself ready, my goggles, I thought these were going to be cold experiments. I'm hot. All right, so what we're going to do is we're going to take that vinegar, but this one's going to happen really fast. So you need to make sure that you do this one over your tub or you do this one over your sink. Okay? Watch what happens. I'm going to take that vinegar. I'll pour that vinegar in there, and we know that this happens pretty quickly. Oh my gosh! Look what is happening. Okay? And what is happening is it starts bubbling out the top, and it even did it. Oh, there it comes. There it comes. It's doing it better. Okay? And so I'm going to add a little bit more to it, but here's the cool part. When I grab the container, it's cold. It's real cold. Okay? As a matter of fact, it happens so fast, I'm going to take a little bit more. Let's see, I got powder in there, but I'm going to get a little bit more in there if I can. Okay? I'm going to get a little bit more. Where's my funnel? There's my funnel right there. coordinate this really good. And this is just such a fast reaction. Okay, it's just such a fast reaction. Okay, I'm gonna try to get a little bit more bubbles in there to try to get it to make my, and so what you're gonna have is you're gonna have a cold foam. Okay, you can't hardly even see that green. I'm gonna not use my funnel this time, but watch what happens as it hits it. Ready, here we go. Look at that just come running out of there. And if you just let that run on your hand, that foam is so cold, okay? It's a cold volcano. Look at it just keep coming out of there. I just didn't use enough soap the first time, okay? It's a cold volcano. It's cold, the bottle's cold, the foam is cold, and the really cool part is when you wash your hands, it's not really anything that's gonna hurt your hands. You might have a little vinegar smell, but just a little soap and it'll come off. This one's really cool. Okay, this one's really cool. So in the last one we had an exothermic reaction, and that was a warm volcano. This one's a cold volcano. Now if it starts to stop, if I squeeze it a little bit, again, small kids can feel that. Okay, they can tell it's cold. Now kids, remember, if it feels cold in my hand, it's taking heat from my hand. So that is endothermic. Okay, really, really cool reaction. Now to just disposal on this one, you're just really washing it out. Okay, wash it out 4 or 5 times, because again, we use bottles a lot in my videos, and so I just wash it out multiple times. Okay, get all the stuff out, and then I'm ready to use it for another one. So I just wash it out real good. I might even wash it out with soap and water, but really the idea is get the chemicals out. But we know that vinegar and baking soda is not going to hurt us. I'll finish washing them out after our video, but that's all you have to do for that one. Okay, that one's really cool. All right, so now in that reaction we did baking soda and we did vinegar, and we did it over the sink because it goes so fast. But I'm gonna do a different one this time, and this time it's gonna be similar but different. I'm gonna use baking soda again, but I'm gonna put it with a different acid. This one is called citric acid. Now, citric acid is gonna be found, okay, we find citric acid. Kids, do you know? Do you know anything that has citric acid? Oranges do, lemons do. Okay, all citrus fruits have citric acid. That's sort of where you get that name. Okay, so candies sometimes have citric acid. If you ever eat those Sour Patch Kids, how sour they are, they have lots of citric acid in it. Okay, and so what we're going to do is we're going to have that acid react with this same base, and it's going to be a little bit different. And so when I looked this one up online, here's what I basically found. Okay, all I have is a box of like little drink mix, and these drink mixes you can get at the dollar store very, very easily. Very, very easily. Now what I'm going to do is I'm going to grab a pair of scissors real quick as Miss Christie shows you the back of that box. And so this is going to be citric acid. It's got to be a compound. It's got to be one of these drink mixes that the first ingredient is citric acid. Okay, that's why it's going to be important. So these are ones I just had at the house. These are ones that we put in a single bottle, mix them up with water, and they're going to have it. Okay, so what you need is, read on the container, you need 26 grams of it. And you think, oh my gosh, I don't measure it like that. Very simply, it's basically 10 of these little things, 10 of them. Okay, so all I'm going to do is I'm going to just cut the end off. I'm going to dump it inside, and these are just the flavors that I have at my house. Okay, but you can buy them at any dollar store. Okay. And so I'm going to drop these in. Now I'm going to be honest with you, when I read this one's super exciting, and everything that it said, I haven't tried this one yet. Why? Because I know that the experiment's going to be similar to the last one, so I'm going to be just as surprised as you are when it happens. I'd happen to have an orange flavor one, and then I have a flavor one that's not orange flavor, but I'm just taking 10 of them so that I have enough for the mixture to work. Okay, and again, all together, one of these boxes has 10 of them in it. So you're using all 10, so it's only $1, okay? And so when I read through the instructions, I thought, okay, this is a great change, that maybe somebody doesn't have vinegar at home, but they do have these little drink mix things, and they're not drinking them right now, or maybe they are, or they have some extras, and so you're just gonna put them together. And so again, I have 10 of them, all right? So what's gonna go with that is gonna be 1/3 cup of water, okay? And so we know that whenever we have this in a bottle, you just mix it with water, and you stir it up. And so that's what I'm going to do first, and then I'm going to react it. So there's all 10 of them. Well, that took me a little bit of time, didn't it? All right, so what I'm going to do is I have 1/3 cup of water. Okay, and I already have it poured in there. It's just room temperature water, and that's a nasty color. That worked out awesome. And so what I'm going to do is I'm going to take that same spoon, I'm going to wash it off because I don't need that yet. I'm gonna mix it really good. Okay. Okay. Got my goggles down so nothing gets on me. Okay, nothing gets on me. And so what's gonna happen in this one is gonna be the same kind of reaction, except it's gonna be this acid is gonna react with baking soda. So there was a weak acid and a weak base when we had vinegar, and this one is a weak acid. It's the main ingredient in all these drinks is citric acid. And so what I'm gonna do is just react it. So I'm gonna mix that in really, really good. Okay. I'm going to, just for grins, let's see what happens if we put a little soap in, because when the reaction, I like the bubbles. Wow, did you see that? That's one of our other lessons, okay, that we had before. Okay, mix in a little bit, and then what we're gonna do is we're gonna move this over the sink, and we're gonna see what happens, okay? And so we're gonna put this right over the sink, and I'm gonna tell you what they said in the instructions are gonna happen, and then we're gonna try it ourselves. I have a 1/4 cup of baking soda. A 1/4 cup of baking soda. Now what's supposed to happen is when you dump it in there, it's going to fizz just like when you had baking soda and vinegar, except it's not vinegar, it's going to be citric acid. And so what they said is it's going to bubble up. That's why I use the bubbles to get even more bubbles. And when that reaction happens, then it's going to be another type of cold volcano. Now, the reason I did it like this is just in case you don't have a bottle, you can do it in a bowl. And so let's see what happens. All right, here comes my reaction. Oh, there it goes. Boy, that didn't take long, did it? Mix it up. Oh, man. And it has that nasty color because I had like a grape flavor and an orange flavor. And the first thing they said is, oh, yeah, when you touch the bubbles, it is cold. If you reach down in the liquid, it's really cold. Or you could touch the outside of the container. It is cold. It is just the same. Now, this one's a lot easier to touch. And why would I do this in the sink? I don't want that nasty on my countertop because Miss Christie won't let me live in the house. She definitely won't let me do laboratory in her kitchen anymore. And so it's really cold and it's staying cold. I feel some of that powder down in there and I can mix that in there and watch. It continues to bubble some. And so that's just sort of nasty. All this can go down the sink. All that can go down the sink. It's just drink mix and sodium bicarbonate. Okay, very, very fast reaction. It was one that I controlled a little bit better, you know, and then it made, look at that nasty. Oh, it made a nasty paste. Wow, but it's cold. It's really, really cold. Now, kids, remember, why is it cold? Because it's taking the heat away from my hand to keep reacting. So what happens if I don't touch it? Where's it going to get its heat? From the room. And if you get close, Miss Christie, you can actually hear it still bubbling. I'll be quiet. You can hear it bubbling. It's stealing energy from the room. So it's going to steal so that reaction can keep going. So what I would do is I'm going to take that substance and I'm going to easily put water into it. And then I'm going to clean all that out in a little bit so Miss Christie doesn't have to, or Miss Christie doesn't get mad at me. Okay? Now, I have the coolest reaction of all that is going to be next. Now, this is going to be our last one today. And this is for people who end up getting dry ice. There's lots of different things you can do with dry ice, and the reason I'm using dry ice is to show you how exothermic and endothermic are very, very different from one another. And so I'm just going to move some stuff real quick to make sure I can show you this one. Now, whenever I've shown this one to my high school students, this one is an instant hit. Okay? This one is amazing. This one works awesome. Now, what we're going to do, so I can explain, and you get the idea of what's going on, let me explain. I need to have a container. And I need to have a container, and this is just nothing but an insulated cup. Now, this insulated cup has a solid straw in it, okay? It's a solid plastic straw. It's not a bendy straw, but it also, that straw, if you look at the straw has a button on it that seals to that. Okay, now I could get the straw out by going this direction, I know that, but I want it to be able to seal. That's what I want this to do. And so this cup will actually seal down, okay? And so what's going to happen is I'm going to make a spray of fog. And so I'm going to tell you before I do it, because when it happens, it goes so quickly. I'm going to put some dry ice in this insulated cup, okay? So I'm going to use my glove, I'm going to get dry ice, and then I'm going to put warm water. So I'm going to go ahead and start the water over here because warm works way better. And so what I'm going to do is I'm going to take and put dry ice in here and warm water. So what's going to happen? Well, here's what's going to happen. Take my glove for safety, put one right there real quick. It's going to do that, except it's going to be different this time. what's gonna happen this time, and I'm definitely wearing my goggles for this, is it's not gonna get out. I'm gonna give it a place to come out. Now, you do not want to do what we're about to do in a closed container that has no way to get out. So what I'm gonna do is I'm gonna do this experiment where all of that can come out this straw, okay? You never want to do this in a container with the lid that's shut. It'll hurt you. But I'm gonna give it a place where it can come out, and I'm gonna use that straw to make it do something awesome, okay? It's gonna build up an amazing amount of pressure in here, and so I'm gonna let it come out the straw hole, okay? So that's what's gonna happen. Let me check my water. Oh yeah. Turn that down a minute. Get myself ready. Gotta get my goggles first. Where did I put them? Woo, found them. This is awesome. Even Miss Christie smiled. She thought this one was cool. All right, so here's what we're gonna do. And then, oh yeah, I forgot the most important part. You need bubbles. Kids, you got bubbles. You need bubbles. Now, there's two ways to do bubbles. Now, for parents, this one's awesome, okay? There's this stuff called glycerin. You can get it at a pharmacy. It's usually on the bottom shelf. And you can mix glycerin with just kids' bubbles, and they hold together better. So like when they go blow bubbles out in the backyard, the bubbles will get bigger before they break. Have you ever seen people that are artists with bubbles and they put all kinds of cool things, they build things with bubbles within bubbles? It's because they add glycerin to it. It holds the bubble together better. Okay, it's just a liquid glycerin. You can get it at a pharmacy, okay? Ask around before you go searching, but a lot of times they have it in a pharmacy. That's where I bought it. I put a little bit in a cup like this with some bubble solution. Now, what I'm about to do, I'm going to do with regular bubble solution, and then I'm also going to do it with mine that has glycerin in it, okay? And so what we're going to make is fog bubbles, okay? So I'm going to get myself ready. Do I have my wand ready? Yeah, my wand is ready. And then I've got, all right. Now, it doesn't always happen the first time, so I got to get myself ready, okay? Got my goggles on, check it out. You need to make sure you have your goggles on. So I'm going to take my glove, open the lid. I'm going to take some of these dry ice pellets, okay? And I'm going to show you what it does, and then I'm going to make my fog bubbles. So I'm going to take some warm water, put it in there, look at it go crazy, but watch what happens when I put the lid on it. I have a place for it to come out, okay? But look what happens when I do this. When I seal it, see that fog coming out of there? So I have pressure inside the cup, and I can direct it where I want it to go. Now, if I don't have it sealing on there, see how I'm losing pressure right here? I want it to seal good. Now, if you don't have a cup like this, if you take some bubble gum, okay, and just fill that gap so when you pull the straw up, just trying to give a space where you don't leak too much. If it leaks some, it's okay. But look what's happening, okay? I can direct where it goes. Now, I'm going to start it one more time because I really need to have good pressure. Okay, and it's going good. I'll pour the water out. I've got some dry ice in there, and it goes away pretty quickly, all right? So watch what happens. All right, everybody ready for this? All right, here's the really cool trick. All right, here's where we do it. Got warm water in there to make that really go good. Take my glove off real quick. Got it. Now, watch my bubble solution. Here it comes. Ready? Woo! Check that out again. Here it comes. Try it again. Check out the fog bubbles that shoot out. Oh, come on. Let me try my other solution a little bit. Isn't that awesome? Okay. Okay, I'm going to try a little bit higher so you can see. All right, try it one more time. Oh, yeah. Oh, yeah. Isn't that awesome? And then after a minute, oh, go, 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 go. That is so awesome. It is full of, oh, I'm out of pressure. Hang on, I gotta start it again. Okay, and like I said, it goes pretty quickly. Okay, pour off the water, get my glove ready. Okay, I gotta get a little bit more. Now what happens is, very quickly, is when I put that dry ice in there and I put warm water, where's the heat going? The heat's going from the water into the dry ice. So the dry ice gets small very quickly. And so it uses it up pretty quick. Let's see how much I got. All right, that'll be good. Warm water makes it go much faster. Okay, put my glove back over here where I know where it is. All right, here it comes one more time. Got it really bubbling. Can you hear that? Drop my straw, so I'm gonna fix that real quick. All right, here it comes. Put the lid on it. And again, I want to be careful. Here we go, up high. Yeah, there's one. Here's another one. Oops. Come on, solution. Ooh, too much pressure. I gotta gauge it out good. Try it again. Yeah! Yeah, let's see if I can catch it on my hand this time. Oh, I gotta get it. I might have to do it one more time. Miss Christie, I gotta do it one more time. I'm so sorry. All right, gotta do it one more time. See how much dry ice in there? Yeah, it's just so, put one water in there again. All right, here it comes. I gotta see if I can catch one. Gotta catch it, gotta catch it. Come on, you can catch it. All right, got my bubble solution. Come on. Come on, Mr. Patrick, you can do it. Oh, get off there. I might not be able to do it. Yeah, I got it. Did you see that? All right, did you catch that, Miss Christie?
I don't know.
Here it comes. Yeah! Wasn't that awesome? Wasn't it awesome? Matter of fact, I have another one for you real quick. Even if they don't know what's going on, you can take a little bit, and this one's been sitting there the whole time. Bet you didn't know. Watch this. Check that out. I had a drop of soap in there. It's going everywhere. And it's nothing but carbon dioxide gas. As I'm touching it, it's just soap. It's just soap. And I'm gonna move it over to the sink so I don't get any more trouble. Look at it go. Look at the bubbles come out of it. Okay? Look at, oh man, that is so cool. We're doing endothermic reactions. A little bit of dry ice. Gotta be safe. Make sure you watch the safety. Hey guys, I got the most awesome thing for you. The most awesome thing. In day 3, I'm putting exothermic and endothermic together. We're gonna have the most awesome time day 3, end of the week. We're gonna make homemade ice cream, and it's gonna be awesome. Parents and guardians, at the bottom of this video, after it's over, you'll see a recipe of things that you can get. But after that, y'all can each make your own ice cream with endothermic reactions, and we're gonna have an awesome time together. We'll see you next time on Mr. Patrick's Laboratory. Have a great time. We'll see you next time.